Hello, AB Calculus. This is what we're calling problem 03AB6. Obviously, this is an equation problem and it's a piecewise function. And also note down here you have a piecewise function where you have those constants that are letters. So K and M in this case are your constants. Remember, especially this year, that's one of the equation type of problems that they can ask because you can't just look this up or punch it in a calculator and get your answers here. So we have f is defined as this piecewise function. So f of x is the square root of x plus 1 from x in between 0 and 3, including 3. And 5 minus x is a linear function between 3 and 5, not including 3. So to know if f is continuous at x is 3, remember the easiest thing to do here is just plug in 3 to both of these. So if I plug in 3 plus 1 gives you 4, square root of 4 gives you 2. And then 5 minus 3 also gives you 2. So at that point, we know the limit exists and that it's equal to 2. Remember, continuous, the justification is one of the hardest things on the AP exam because it involves three things. So you first need to show that the limit exists. Once you've shown the limit exists, then you can go on to continuous. And then later on, once you've shown that it's continuous, you can look at differentiable. So remember, it always goes limit first, then continuous, and then differentiable in that order. And if they start off with differentiable, then you automatically know it's continuous at that point and that the limit exists at that point. So you can go backwards. And all three of these things are true if they just say differentiable. Okay, so first I need to establish that the limit exists. So I need to say the limit as x approaches 3 in this case from the negative side. From the negative side, that would be this top function, square root of x plus 1, because 3 from the negative side would be numbers less than 3, and numbers less than 3 would be in between 0 and 3. So I could say the square root of x plus 1, and I know that's equal to 2. Because again, the square root of x plus 1 is a continuous function, so I'm allowed to just plug in 3 from the negative side, and that's going to approach 2. And then I can say the limit as x approaches 3 from the positive side, and this time we're talking about 5 minus x. So you plug in 3, and that's also 2. So since these two things are equal, we know the limit exists. So we can say the limit as x approaches 3 of this piecewise function f of x is equal to 2. And that's the first thing I need to show is the limit exists. Second thing I need to show is the function is defined at that point, which in this case is 3. So f of 3 equals, well, because this is equal to 3 here, technically I'm plugging in this one. So 3 plus 1 is 4, and the square root of 4 gives you 2. So I can write f of 3 is equal to 2. That's the second thing they need to see. And then the third thing they need to see or you type out is that these two things are equal. So the limit as x approaches 3 of f of x is equal to f at 3 because both of those things are equal to 2. So that needs to be there. The limit exists. Second thing is the function needs to be defined. And the third thing is those things need to be equal. Those three things always need to be there on your justification for continuity. Okay. And if you just plug in 3 and you get 2 and 2 and you don't do these things, they're not going to give you any points because this is the formal calculus definition of continuity. Okay. All right, for B, keyword or phrase is average value, and that is going to be the 1 over b minus a, integral from a to b of f of x in this case, and we're going from 0 to 5. Now for a piecewise function, we got to watch out because 3 is the dividing point between these two different functions, and 3 is in the middle between 0 and 5. So my setup's going to be 1 over b minus a, and a is 0 and b is 5, so that'll be 1 over 5 minus 0, or 1/5. And then it's the integral, and I'm going to put this in a bracket because this 1/5 applies to all of this. And then I'm going to integrate from 0 to 3, the top function, which is square root of x plus 1 dx. And then plus the integral from 3 to 5 for the other function, 5 minus x dx. And then close that bracket around. Okay. Now in a normal year, you would have to actually integrate this. This would be u substitution and we make it x plus 1 to the half power. But because anybody can plug this in a calculator and get the answer, they're probably not going to be able to ask this for you to actually do this year. So the most they could probably ask you would be just to set up the problem like that. And that would be the setup for this problem. All right, for C, now we have a function g. So we have a function g that's a piecewise function, and it's defined by these two pieces. Again, k and m are constants. If g is differentiable, again, if g is differentiable, that means g is also continuous, which also means the limit exists as you approach 3, and you're trying to find the values of k and m. Okay. So the first thing I'm going to do is plug in 3 for both of them, just like I did up here to show that the limit exists. So if I plug in x is 3, 3 plus 1 is 4, square root of 4 is 2, so the top becomes 2k. And then when I plug in 3 on the bottom one and set those equal to each other, that'll give you 3m plus 2. Now at that point, I can't solve this equation for k or m because I have two variables and only one equation, so I know I need a second equation. So the fact that it's differentiable means I can take the derivative of both of these. So g prime x, and again, this is my piecewise function. So for the derivative of this one, let's just go off to the side here and write this as k, and then x plus 1 raised to the half power, so square root's 1/2 power. And this will be power rule with chain rule when I take the derivative. So the 1/2 comes out front. K will still be there because it's just a number. It's a coefficient. X plus 1 stays the same. Subtract 1 from the exponent to finish your power rule. And that gives you 1/2 minus 1 is -1/2. And then for the chain rule, times the derivative of the inside, but the derivative inside is just 1, and times it by 1 doesn't change anything. Okay. Now, since I have a negative exponent and a fraction exponent, since it's a negative exponent, this x plus 1 term is going to go back to the bottom, and the half power will be the square root. So I'll rewrite that as k on top over the 2 from the half will be on the bottom. And again, this goes to the bottom as the square root of x plus 1. All right, now for the second one, that one's easier. The derivative of mx is just m, and the derivative of 2 is 0, so that derivative is just m. Okay. So my second equation comes from setting these two things equal together. So m is equal to k over 2 square root of x plus 1. And if the function is differentiable, or g is differentiable like they told me, then I know these two things have to be equal, or the limit of the derivative from one side has to equal the limit of the derivative from the other side is technically what I'm doing. Okay. All right, so now I just need to figure out the easiest way of doing this one. And actually what I should do now is plug in x is 3 here for this one. So this will be 3 plus 1 is 4, square root of 4 again is 2, times 2 gives you 4, so m is equal to k over 4. Okay. And now I just need to do a substitution probably. I'm going to replace this m here with k over 4 since that's what it's equal to. So I get 2k equals 3 times k over 4 plus 2. I'm going to subtract this on each side. So 2 is 8/4 minus 3/4 of a k gives you 5/4 k. If you need to write that out, go ahead and do it. Equals 2. Best way to get rid of 5/4 is multiply by the reciprocal, which is 4/5. So that gives you k is equal to 8/5. And then once I know that, I can solve for m. So m is going to be 8/5 divided by 4. And remember, it's totally okay to leave it like that since it's fraction over a fraction, and a lot of you don't like fractions. We'll just stop right there. Okay. All right, so this is a possibility of something they could ask, especially with these constants here, k and m, since you can't just plug this in a calculator or plug it in an internet app in order to get the answer for these. It's something that you'd have to be able to do.